All right, 11.93. Okay, so I changed the question a little bit. We're going to answer the questions they're asking, but so it gives the density. It is scandium. The periodic table. So they give the density. It is 2.99 grams per centimeter cubed. You find scandium on the periodic table. The molar mass is 44.96 grams per mole. All right. It tells us that 74.1% of the space is occupied. All right. And so again, you have your 52%. That's simple. L is equal to 1. You have your 68%. That is a body-centered. L is equal to 2. And then you have your 74%, and that is face-centered. And that is L is equal to 4. So the 74% will tell us that it's face-centered, and the L value is equal to 4. All right, volume of a sphere. So your atoms or volumes, they are spheres, 4/3 pi r cubed. All right, and so the question that I'm going to change it to, we're going to answer the actual question was calculate r, but I'm going to have more than that. So it's going to be calculate the length of a side A, calculate the volume of the cube. That's going to be calculate the radius, which was the question in the problem. And then once we have that, we can calculate the volume of the sphere. All right, so the equation that you're going to need for this problem is the volume of the cube is equal to length times width times height. That is your edge length. It's a cube. They're all the same. Length, width, and height, A, and A cubed. And that's mammal DNA. All right, and so we will plug in our numbers in the correct units. Molar mass, that is the correct units, grams per mole, 44.96. L, we have 74%. That is a face-centered where you have 4 atoms in the cube. And then you have your density given, 2.99 grams per centimeter cubed. And then you have Avogadro's number, which will be given. It's a constant, 6.022 times 10 to the 23rd atoms per mole. And so this is 4 atoms in the cube. So the atoms will cancel, the moles will cancel, the grams will cancel, and you're left with centimeters cubed. And so you're going to get centimeters cubed for your volume. And then when you take the cube root of that, you will get the length of a side A in centimeters. And if things are working correctly, your units will be 10 to the minus 8 centimeters for A. All right, so you put in your 44.96, multiply that by 4, divide that by 2.99, and divide that by 6.022 times 10 to the 23rd. All right, and so you get your volume of your cube, which was a question. So here's the volume of the cube. And that is 9.99 to 3 sig figs because of the density, times 10 to the minus 23. And the units are centimeters cubed. That is the volume of the cube. All right, and so then we know that that's equal to A cubed. So we take the cube root of both sides. And we get an A value. And so A, when we take the cube root of that, so A is the third root of 9.99 times 10 to the minus 23 centimeters to the third. And so your A value is 4.64 times 10 to the minus 8. All right. If it wants it in angstroms, it is 4.64 angstroms. Because remember, an angstrom is 10 to the minus 10 meters, and so that is 10 to the minus 8 centimeters. All right. So if it doesn't say what the units have to be in, I would just leave it in centimeters. But if it says angstroms, then it's 4.64 angstroms. All right, so now we need the radius. All right, and so remember how we did the face centered. When you do the radius of face centered, you got your A value, you got your A value. Face centered is going to have 1 at each corner. Bigger. 1 at each corner. And then 1 in the center. Okay, so the key here is if you draw the picture correctly, you have 3 of these spheres, all the same radius. And so we're going through right here, we're going to use Pythagorean's theorem, where we have a squared plus a squared is equal to c squared, but the hypotenuse is 4 radiuses. All right, and so you got 2a squared is equal to 16r squared. And so you have radius for your face centered. When you're going to divide both sides by 16, and then you're going to take the square root. And so it is the square root of 2a over 4. And so when you want the radius, you simply take the square root of 2 times your a, 4.64, times 10 to the minus 8 centimeters, divided by 4. You're going to have 3 radius equations given to you. You're going to have to know which one to use, and this is the one you use for a face centered. So you take the square root of 2, you take your square root of 2, I'm just going to look at points. All right, so when you push the buttons, you get 1.64 times 10 to the minus 8. Or 1.64 angstroms. So again, it depends on if it's specific to the units. If it's not, leave it in centimeters. If it is, the units will always be in angstroms. So when you given the problem, if you're given A or R, it's always going to be given in angstroms. All right, and then just to find the volume of the sphere, volume of your sphere is 4/3 pi r cubed. So you take that to the third. Times pi times 4, and then divided by 3, and you get the volume of the sphere 1.85 times 10 to the minus 23. All right, and so we can check our percent. And so remember, the volume of your atoms divided by the volume of the cube times 100 is our percent space occupied. All right, so the volume of the cube, 9.99 times 10 to the minus 23. Centimeters to the third. Volume of your cube. That's the volume of your cube. Volume of your atoms. Okay, now you need to know again that you have 4 atoms in this cube, and each one of those atoms has a volume of 1.85 times 10 to the minus 23. And that is centimeters to the third. So whatever volume units, it doesn't matter if you have angstroms to the third, but then the bottom would also have to be angstroms to the third. Okay, so 4 divided by 9.99 times 10 to the minus 3. And you get 74.0%. So this is 74.0 to 3 sig figs percent. Pretty close. Let's see. Oh, that's a 1. All right. So it is a 1. 74.1%, which is what they gave in the question. So that confirms that you did everything correct. And so you go back to what was given, and they say that the percent space occupied is 74.1%. All right, so you could have done this problem different. You could have started where I ended. And you would have said, okay, I know that it is 74%. You could have solved for the volume of the cube because we had all of that. I guess we didn't. Well, again, you would have to know that the L value is 4. So 74%. So yeah, you would have to know that that's space centered and the L value is 4. Yes. Yes. All right, so I have C on all 6 spaces, I have P on all 8 corners, and I have oxygen O in the center. What is my formula for this compound? How many C's are in the cube? 3. How many P's are in the cube? 1. How many O's are in the cube? 1. What is the formula? Say it. And so, okay, all right. I don't know if you get it. But anyway, what is it? I don't know. Does anybody know who that is? Yes, all right. So, right. That's your Star Wars quiz for the day. What is going on? All right, fine. All right, we're recording. All right, so we have R on 8 edges, D on 8 corners, and in the center. What is the formula? And the last answer gives this answer away. That is R2D2, correct. So why is it R2D2? Right. And the corners are 1/8, and the center, the whole thing's in the middle. Right. So there are 2 R's in the cube, and there are 2 D's in the cube. So that is R2D2. Yes. Yeah, that's about as far as my Star Wars knowledge is going to go there. All right, so you have to know that your edge is a quarter, corner is an eighth, center the whole. All right, so 12.69. All right, so we have glycerol. We have 0.133 grams, and that is C3H8O3, and we have 20 grams of water. And the question is to calculate the boiling point and the freezing point. So we need to find the delta T sub B, and that is the I Kf C sub M. All right, so what is your I value? 1. So anytime you have a molecular compound, the I is 1. All right, only time I is going to be different than 1 is if you have an ionic compound. All right, so your delta T sub B, that's 1. That should be a B, not an F. We're doing boiling first. So you find your KB, because we're doing boiling first. And so we have, for water, it is 0.512. That will be given. All right, and then C sub M, what is that? What do we have to do to define C sub M? Molality. So what's the units for molality? Right. So how are we going to find moles or solute? So divide by the molar mass. So we got 36, we got 8, we got 4, and then we have 16 times 3 is 48. So you got 92. Anybody get 92 for the molar mass? Yeah, okay. All right, so 92 point, let's see, we got 381, probably 1 more grams per mole. All right, so when we take our 0.113 and divide by 92.1, moles is 0.00123. All right, so that's moles of our solute, C3H8O3. All right, and so now all we have to do is take our 20 grams of water and convert it to kilograms. And K is 10 to the third. 20 divided by 1,000. All right, calculator for that. All right, so you got 0.0200 kilograms. And so now you're just going to divide those two numbers. To get the molality. And that is a 0.0613. All right, so then you just plug that in right here. So the molals cancel, and you have your delta T sub B in degrees Celsius. All right, so times 0.512. So you got a 0.0314. And so the boiling point is 100.0314 degrees Celsius. So you have a boiling point elevation. It went up by 0.0314. Right. If it's a different solvent, then it has to give you the boiling point, and then it goes up from that. And then the freezing point, we're going to do exactly the same thing, except you have your Kf instead of your Kb. So your delta T sub F is equal to I Kf C sub M. And your I value is still 1. You look up your Kf, 1.86. degrees Celsius per molal, and then you have your molality, 0.0613. And that will give you your delta T sub F. Which is 0.114. And so that is a freezing point depression. We know water is 0, and so it goes down from 0, 0.114. So the temperature of freezing is negative 0.114 degrees Celsius. All right, so 12.59, you've got a 0.650 molal of sodium hypochlorite. And the question is, find the mole fraction of sodium hypochlorite. All right, so again, what are my units for this little m? Little m is not helpful, so you should change it to what? Right, in this case, the solute is NaClO. All right, divided by, which in this case is water. All right, so we have kilograms of water. So again, there's no number. It's understood that it is 1 there, 0.650 moles per 1 kilogram of water. All right, and so we need the mole fraction. So to get the mole fraction, we need to find the moles of NaClO, and then we also need to find the moles of water, because in the denominator, part over whole, we have to add the moles of our NaClO to the moles of the water. All right, well, we already have the moles of the sodium hypochlorite. It's 0.650. So now we just need to find the moles of water. So we have 1,000 grams, a kilogram is 1,000 grams of water. Divide that by the 18.02 grams per mole of water. That get 55.5 moles of water. So you plug that in there, 55.5. So you add to that your 0.650, and so your denominator, so you have 0.650 in the numerator, and you have 56.1 in the denominator. And so when you take your 0.650 divided by that, you get 0.0116. I did not clear my calculator. I left it as the 55.4938. So again, if there's any difference in the last decimal, that is just if you clear your calculator and retype it in, or just use the entire number. All right, so that's your mole fraction. If you wanted the mole fraction of water, they have to add up to 1, so that would be a 0.9884 would be your mole fraction for the water. Or you could take your 55.5 and divide by your 56.1. Again, if you do it this way, you're only going to get 3 sig figs. If you subtract it from 1, you would get 4 sig figs. All right, 11.47, we have ice at 0 degrees Celsius. And the delta H of fusion is given, and that is 6.01 kilojoules per mole. Right, so that's the heat of melting, the heat of fusion. All right, and then we are going to have water, liquid. This is H2O solid. All right, we got water liquid at 55 degrees Celsius, and we have 64.3 grams of it. And the specific heat of water is given as 4.18 joules per gram degree. When we add this certain amount of ice, so the mass of ice, all right, so we added some mass of ice to this water, and our final temperature is 15 degrees Celsius. All right, and so your water is going to this, and your ice is going to this. All right, so your heat gained is equal to heat lost. All right, so the heat gained by the water, heat gained by the ice, is equal to the heat lost by the water. All right, so this 55 is cooling down, the 0 is heating up, the heat gained by the ice, and they are both, when they are done, all right, it's going to be 15 degrees Celsius, and all the ice is melted, and the water cooled down to 15. So the question is, how much ice did we have to add in order to get it to 15? All right, so you have two processes with your ice. I like to draw some pictures. All right, really a picture. I'm not a picture person, but here's my ice at 0 degrees Celsius. All right, and so what I'm going to do is I'm going to make it water at 0 degrees Celsius. So first thing I have to do is I have to melt it. So I'm going to take my ice and I'm going to melt it. So remember, your heating curve looks like this. All right, and so we're here at 0 degrees Celsius. All right, and so we're starting at ice at 0. So we're starting here. And then over here, we got our water at 55 degrees Celsius. And then we're going to end up being down here because this is going to cool off. And so this is going to heat up. But before you can heat this up, you first have to melt it. So you have to go here first, which I'll call Q1, and here second, which I'll call Q2, and that has to equal negative, I'll call that Q3. All right, and so here is Q1. So I need to find the Q to melt the ice. Then I have to find another Q, Q2, to go to that is still going to be water, but now it's at 15 degrees Celsius. All right, and so on this side, I have my water, and I have the amount, 64.3 grams. All right, and that's at 55 degrees Celsius, and I have to cool that down to 15 degrees Celsius. So when I'm done, I'm going to have the mass of water plus the mass of ice in my 15 degrees Celsius here. So I have my ice and my water. So my ice melted, whatever mass that is, plus the 64.3 grams here. All right, so in order to get Q1, so that is going to be moles times delta H. All right, so we're melting it, heat of fusion. All right, to get Q2, Q2, that is increasing temperature. That equation is MS delta T. Q3 is also changing temperature. All right, and so we need negative Q3, which is MS delta T as well. And so we're going to add Q1 plus Q2, and that is going to equal negative Q3. That is, your heat gained is equal to heat lost. All right, but we can only have one unknown, and so we have moles here and we have mass here, and the question is, what mass of ice had to be added? All right, so in order to get moles, remember, in order to get moles, you take the mass and divide by the molar mass. All right, and so for Q1, I'm going to do that substitution. I'm going to put in mass divided by the molar mass. And also, they have to be in the same units. And so I'm going to work in joules. And so my Q1 is going to be mass divided by molar mass times delta H. And then Q2 is right there, ms delta T. All right, so now Q1 and Q2, my mass is ice. So this side is ice. This side is the water. All right, so on this side, my negative Q3, I know my mass, it is 64.3. All right, and then the S value is for water, it is the same. All right, so let's plug in what we have given to us. We don't know the mass. We know the molar mass of water. The molar mass of water is 18.02. We know the delta H because they gave it to us, 6.01. Now that's in kilojoules times 10 to the third joules per mole. All right, and so the mass here is going to be in grams, and you end up with joules. So Q2, so plus my Q2 here, is the mass of the ice, which is what we don't know. The S value is given, 4.18 joules per gram degree. They put degree Celsius, I just put degree. And so delta T, temperature final, 15 degrees Celsius is our final temperature, minus, we are starting at 0. This is the ice. All right. And so that is equal to negative Q3. And so, so what we're going to do on the left side is note that we have a mass, we have a mass. So we're going to use our mass skills, and we're going to pull out M. And so that gives us 6.01 times 10 to the third divided by 18.02 plus 4.18 times 15 minus 0 is 15. All right, and so I pulled out a common factor of mass. All right, and that is equal to negative Q3. So let's plug in the numbers. So negative, the mass of the water, 64.3 grams. The S value is 4.18 joules per gram degree. And then you have a delta T, temperature final. Final temperature 15, initial temperature 55. All right, and so that's where the negative is going to come out. So you have a negative out in front. 15 minus 55 is negative 40. Negative 40 times the negative out in front, and you're going to end up with a positive value. All right, so now we just get our calculator and push the buttons. 6.01 times 10 to the third divided by 18.02. All right, so underneath here, I can write the number. It is 333.52. That's more sig figs than you need. All right, so to that, we're going to add 4.18 times 15. All right, so on the left side, when we do that, we get mass, and then this number in the parentheses is 396. And I'm going to put it at 0.22. I don't need that many sig figs. At the end, I will round it to the correct number of sig figs. All right, so then on the right, I take my negative 40 and times the negative out in front. The negative 40 is from the temperature, and then multiply by the 64.3 and multiply that by 4.18. So on the right side, I get 10,750. .96. All right, and so to solve for the mass, I divide both sides by the 396.22. And I get 27.1 or 27 since you're, when you do your delta T's, you keep getting 2 sig figs, so it should be 2 sig figs, 27 grams of ice. All right, so 12.79, we have a 0.0075 molal, little m, calcium chloride. All right, and we want the freezing point, right? Is it freezing point? For this solution. So the key to this one, so we already did freezing point, delta T sub F is equal to I K F C sub M. It would be exactly the same, except this is not a molecular compound. This is an ionic compound. All right, and so when you have an ionic compound, your I is going to not be 1. The I value here is going to be what? So how many ions will be in this solution? So all of your halides are soluble except for silver, mercury, lead. So this one is soluble. So you're going to end up with a calcium plus 2 and 2 Cl minuses. So your I value is 1 calcium ion and 2 chloride ions. So your I value here is 3. So your delta T sub F, you have to put the 3 in there, and then 1.86, and then the molality that they gave you, 0.0075. So 3 times 1.86 times 0.0075, and that gives you a delta T sub F of 0.0419. Oh, it's only 2 sig figs. 0.042. And so the freezing point is negative 0.042 degrees Celsius. So delta T sub F is your freezing point depression, so it has to come down, and this was in water, and so it's negative 0.042 degrees Celsius. All right, so 12.65, we have a vinegar solution, which is acetic acid. Right, and so you have a 0.763 capital M of your HC2H3O2, and that has a density of 1.004 grams per milliliter. And the question is to calculate little m, molality. All right, so again, you must know your units. So what's the units for big M? Moles of what? Solute over liters of solution. All right, so our solute right here. So we have our moles of our HC2H3O2 because we are calculating molality. Again, what's the units for that? Moles of solute divided by solvent. All right, well, we have half of it done already. We already have our moles of solute, 0.763. But that is per liter of solution. So we have 0.763 moles of this when we have 1 liter of solution. What are the units of density? Grams of what? Milliliters of what? So grams of So your choices are solute, solvent, solution. Solution. Volume of grams of solution and milliliters of solution, both solutions. All right, and so we have liters of solution. Now we can find our grams of solution. So we have 1 liter of solution, which is 1,000 milliliters of solution. And we now know that we have 1.004 grams of solution per milliliter of solution. And so now we know that we have 1,004 grams of solution. All right, and we know that the grams of solution is going to be the grams of water and the grams of our vinegar, HC2H3O2. When we add those two numbers up, we get our grams of solution. All right, and we need to find the grams of water converted to kilograms, and we will have our answer. So how are we going to get our grams of acetic acid? All right, so we have the moles, and we can just multiply by the molar mass, and we will have the grams of acetic acid. So 0.763 moles of acetic acid and we need to multiply it by the molar mass, grams per mole. So we find we got 24, we got 4, we got 28, we've got 32, 60.06 grams per mole. So you have your 0.763 times 60.06, and that is 45.8 to 3 sig figs. 45.8. So we have 45.8 grams. And so we take our 1,004 and subtract our 45.8. And so that means that we will have 958.2 grams of water. We add those up, we get 1,004. All right, and so now we have what we need. We have our moles, and now we have our grams, which can easily be converted to kilograms. So the molality is your moles, 0.763 moles, divided by, we just have to convert that to kilograms, so divide by 1,000, 0.9582 kilograms of water. So 0.763 divided by 0.9582, and the 3 sig figs, it is 0.796.